Um, so first of all, that was nice. That was nice. Thank you for finishing talking about the content and then you stopped talking. That's exactly what I'm looking for. So very well done. Could you show me just kind of in the air in front of you, on the whiteboard in front of you, show me what this regression plot would look like? Okay, something. Let's see. Now for regression, there is that middle line, which is 0. And we can see that here, all of these points have a residual that is negative. Does that make sense? So if you were to plot them, it would look something like this, and it's getting closer to here where the residuals are close to 0. Does that make sense? And this is complete just estimation. And here, all of those are now positive. So if I were to actually graph those, it'd be here. And then it comes back down here where they're kind of close to 0. The residuals are here. Those residuals are quite negative, aren't they? They're all under that predicted value. So the plots are the actual values and the graph is a predicted value. So those all become negative. So if you're just to look at this residual graph, you would say about a regression that it is inappropriate. Does that make sense to be inappropriate? Yes, Simran, you have a question?
Yeah, is it actual minus the level graph or the graph minus like value on the graph minus here?
It's actual minus the predicted. So like this point over here, you would subtract from it this point that is higher.
Yeah.
Yeah. So anything below is negative. Anything below is positive. Max.
For it to be appropriate, does it need to like kind of just follow the 0 line?
Oh, good question. What do you think? Would that make sense?
I say yeah.
So, and yeah, it just has to be around 0 with no sort of pattern. Like here, there's definitely some sort of pattern happening. There's an area where it's below, another area that's above, and there another area that's below. And this is kind of that's already day 6 largely. Oh, sorry, day 5. So let's take a look at the actual packet for day 5. Right, so we're talking about only 3 different types of regression. So 2.6. Actually, let's go here. Yeah, basketball could be talked about another time. Unless we're taking some sort of data. So go ahead and it says to plot these, but maybe you can figure out what kind of regressions would be appropriate and model be appropriate just by looking at them. Do you all see where we are?
Yes.
It's in 2.6, beginning 2. Near the beginning of 2.6. So go ahead and discuss with the neighbor what kind of model would you use here?
All 4.
All 4.
Yeah. So
This one looks really quadratic.
Okay. This is
Wait,
If you want to plot them, you may, of course, but
0 to 11.
choice is yours.
yeah, quadratic. It's concave.
It's kind of linear.
Third one is
I'll call 4 like individuals in just a moment.
third one
The
is
first one? You're stealing all the
discussion
negative
change.
ones. Yeah.
Lee, do you think three?
I said exponent.
Do you guys see the one?
Yeah. D is exponential like D, right? Pretty sure. This is just yes.
Yeah, these right.
One is linear.
Maybe it could be one.
There you go.
Wait, because protection.
Or
It has individual.
No, they don't need the exact. It's a guess. It's the best fit.
He's kind of also.
Are we ready?
It's more like it's like a square root.
So I'll be asking what kind of model would be appropriate and why you think that. In just a moment, I'll give you another few seconds. Or it seems like you might be ready. Kayla, can you help us with A? What do you think this is? What makes you say that? And moving up by a constant rate? Is it? Okay. Are we good with that? So linear? Nice. Should we use like y2 minus y1 or anything? Should we actually find the slope? You can see it, everyone's a little bit different, but close enough. It's close enough where it's linear regression is appropriate. Thank you, Kayla. Nia, can you help us with B?
I said that it was quadratic.
Okay.
It like kind of went up and then it came down and it looks kind of symmetrical on both sides.
Okay. Nice. Yeah, I think that once you have the going up and going down, it's kind of over. If you have to choose from these three. And you have that symmetry too, so perfect. Thank you for that. Any questions? Okay. Max, help us with C.
So I plotted all the points and I got exponential. And I think it's like, because it's going like, it's like kind of smooths, it like slows down towards, as it reaches like the horizontal asymptote, which is 0. So like,
Nice. Thank you. Do we have to graph it to look at it?
I mean, you can just kind of tell that it's like the values are going from higher gaps to like smaller gaps.
Yeah. Specifically, it seems like there's a common ratio of about 1/2, doesn't it?
Yeah.
And so just this one happens to be pretty easy. Okay, thanks, Max. And Lee, can you help us with D?
Yeah, for D, I thought like it was an exponential graph going upward.
Are we good?
Yep.
Nice. Now, you do notice that there's one thing that makes these fairly easy to determine. Do you look at, yeah, do you know what I'm talking about? Yeah,
Constant like increase within max values.
right. Does that make sense? So that's kind of key to this, to judging the Y values. So if you're just looking at the numeric values, since these are all evenly spaced, yes, we could assume that linear, exponential, quadratic change. So just make sure that if you're looking at that, you're considering the delta X as well as those changes in Y's, just in case. Yes.
I'm kind of confused. What does delta X have to do? Like,
Yeah, well, good question. So let's talk about the one that you were talking about, because this was, oh, you did D, didn't you? You did C, excuse me. I focused on this and then said D. If this is like 2 and then this is 4 and this is like 9 over here, or then it just kind of like, it may change the flavor of what's going on.
so it can make it seem like it's like a quadratic when it's really exponential.
More, it could look linear even though it's exponential.
Oh, okay. So because it's so tightly like spaced, it's like you can see the growth.
Yeah, I think this could all be a line. If we started at 10, it could go down to 0.7. It's just the 10 would be here at 1, and then the 5 would be over here at like 5, and then 2.4 would be over at 7 or something. You know, these Y values could be exactly the same on a line. But because these are so evenly spaced, each one is half within that space.
Yeah.
But yeah, I hope that makes some sense here. Etc. So we can get those same Y values just a little bit differently. So make sure you just looking at the whole picture, the X's and the Y's. Here, it was easy to just look at the Y's because the X's were all very evenly spaced. It was predictable. Okay, let's try a little bit of these examples 3 and 4. Interesting. Discuss when you're ready.
Wait, 3 through still.
Just 3 and 4. 3 and 4.
What's the protein in here? Sorry.
I think that residual plot is the model data says for the residual plot should go around out. Stay back to the first one. Yeah.
Yeah, I live.
If you see a clear pattern. Oh, yeah. Looks like above.
I think the answer is
Yeah, but
C.
I think that's the answer. I guess. Right. It's
It's
not like, it's not like.
But it's also.
Well, yeah.
It's not
Is it appropriate?
It's appropriate. Yeah, there's a pattern. I
Oh, sure, I have to do example.
I don't think there's any pattern. You think that there's a pattern? I don't see any pattern.
Okay, that's if it's.
That you don't know it is not. Yes, it is. Or you don't. Look at, think back to the first round that we did at the start.
Doug, this is talking about the residual. It's talking
Yeah.
about the difference between it. It needs to be closer to
We
zero.
talked about the residual.
Yeah,
First
but
problem
there's
too.
no, but there's no, there's.
I feel like it's appropriate. It looks really appropriate.
Oh, yeah, we should be your small.
Okay, ready?
Have to be, well, yeah.
Let me see your knowledge of ASL. So let's go over it. Yeah, so let's just go over the first 4 letters. Yeah, so A in, I'm not saying it's the answer, but A in American Sign Language is A. I think it's with your nails showing. B is this one. I think there's a B right there, maybe. C. C, yeah. I don't think you have to turn. I think there's just C. Of course, you can see the C if you turn it. And D. That one is this. D is the D right there. It's in D. You have a question? So A, B, C, D. This is I, and J is. Scoop it. Kind of cool. Okay, so I'd like to know your answer for example 3. I'd like to know your answer. Is it A, B, C, or D? So take a look around and see what people are saying.
Wait,
Okay.
what?
So I see a lot of C. I see a lot of C. I'd like to hear from Judy. What do you think? Is it C? And what? Why?
If there's no pattern, it means that the graph is like the residual is like it's going around the graph that and not in a pattern, so it's like suitable for the graph.
Okay. Good. Yeah, perfect. I think that puts it into words what I'm looking for. Does anyone want to expand on that? Yes.
I just felt like there were an even amount of dots like over and under like the 0 line.
Yeah. Okay. So even amount above and below. Okay. Any other expansion of concept? I like the contrapositive, like if there were a pattern, right, if there were some sort of pattern, like somewhere below, some below, it would be like what we did for the warm-up today. It would just not be representative. You need even above and below without a specific. Thank you, folks. Example 4, a group of AP pre-calc students use a set of data to create a linear, quadratic, and exponential regression model from the same data, I'm sure. Here's a residual plot for all three. Okay, so let's call this A, B, and C. Which one is what we're looking for? Yeah, it is C. Again, no pattern. There's same above and same as about the same above and same as below. Yes, August.
I'm just curious, since it's about like the same both below and the same above, would that technically be like a pattern because it's like above below kind of?
A good point, because here I think it's the same above and same below, isn't it, for this one? But there's a pattern here. So all these being negative, and then all except for that one, but these generally being negative and generally being above, means we didn't cut through the middle of whatever data we're having. We need to cut through the middle. So, and this one, same issue. Just all these residuals being below, we just think cut through the middle, like with the warm up, with this one, right? This one, I've shown you this before, right? And this is largely, maybe this is right. It's generally going through the middle without a pattern, but yeah, this one looks like it has a lot of down here. Just kind of strange. It should be random going through ultimately. And the more data points there are, the more random it would be. More random it would look like. Whoa. It's not what I wanted to do. Okay, let's continue. With so we finished day 4. Done with that. I think that's enough. Let's do day 5, right? It's super short. Composition of functions.
It's pretty.
Right, that's so quick. So composition. And this is review. So we're 2.6. Just,
That's that my like to my math teacher.
yeah, that sounds nasty.
Actually, no, the one that really annoys him is whenever I describe
Example
who the quadrant says alternating state calculus. I don't know why
That's
that's
the worst. For trigonometry.
trigonometry.
Okay, can you find this in your 2.6? Try these 3, check with your neighbor. Don't do them together, just check.
Maybe example 40.
Yeah, example 2, please.
Oh, we got them.
6.
Oh my gosh, I'm on a roll.
Yeah, 69.
Yeah.
Wait, how do you do the third?
It's 18. 16.
So what, do we have to do? I forgot.
That's nice.
Oh wait, no. 9 minus 5. Yeah, 16. Oh, wait, no. Yeah, no, 3 times 2. Yeah. G of prop 4. 8. 9.
Even what?
Yeah.
Yes.
Go up to.
Brian.
We move on.
Not yet. Just Brian passport.
My passport.
Alrighty, got it.
Okay, show me your answer for A, please. Somehow. Show me your answer for A.
Yeah. Okay, I got it. Like, wait.
Wait.
It's really rude. No, that's not.
Oh,
Um,
I know this. No, I don't know.
Which is that's.
Yeah, that's true.
Oh, in sign language, does anyone know what 16 would be in sign language? Do you know 6? Did I tell you 6? I didn't go with sign language numbers. Oh man, 1. Oh, close. 1 is this. 2 is this. 3. 3 is not. 3 is this. 4 is this. 5. Surprise. Is this 6? Anyone know 6? 6 is this, which is why this is not 3. This is 6, 7,
You fluent in sign.
8, 9, 10. Yeah, so 6, 7, 8, 9, 10.
To this.
Yeah, it was shake. Yeah. I think this is A. Right, so 16, I think, is at 10-6. I think 10-6. 6.
Wait, what's 8?
Yeah, so 16 if you want to do ASL. 10-6. And this is not 13. 13 would be 10. 10 what did I say? This one. This one, 10-3.
So
Which one?
Six.
Is there a pinky one?
The 6, 7, 8, 9.
6.
This is I. Now you need one hand. 6 and 10. 6 and 10. Yeah.
Wait, you do the 6 first?
I think so. Oh, maybe it's 10 and 6. Yeah, I'm not sure. Yeah, I was in a sign language club in high school, so this is like this is old memories. I remember the numbers up to 10 for sure. Yeah. Show me your answer for B. And you can show me this normal. Right. So yeah, this works too. This is 9. Good. And C, I have no idea how to actually say negative in sign language, but for us, yeah, -2. Okay. Easy. -2. Well, we do this just to keep it one-handed. But that works too. Example 3, could you take the equations from example 2 or the function from example 2 and compose them? Pretty sure your neighbor got the same thing you did. I'll be calling 2 people just to give us the answer because that's too much to give with fingers.
Oh, it's 6.
Oh, I got 6 up there. Already got it.
-2.
Oh, yeah. Already, I got both.
You got both? Ready? Connor, can you tell us what you got for A, please? Just the answer. 3A. Yeah. 6x minus 2. Do we agree? Okay, thank you. And for B, Oliver, can you tell us what you got?
I got 6x minus 9.
6x minus 9. Do we agree?
Yeah.
Okay, thank you. If you're not sure where those came from, there will be time in class to go over those just before the quiz. But last thing I want to talk about is I want to finish up some of the notes from last time, which I didn't quite get to. And I think this would have helped you with your assignment. So if you, yeah, let's do example 5.
Oh,
Do we do this? Right, get to this.
Wait, this isn't on the list, is it?
This is not on the quiz. No. After 50 deer were introduced to a large wooded area. The population of deer in the wooded area can be modeled by the exponential function d of t equals a times b to the t, where t represents the number of years since deer were first introduced. Okay. It says that deer increased by 13% per year. So d of t, is this a difficult problem?
No.
It's actually pretty straightforward, isn't it? D of t is equal to
50
50.
times 1.13.
Exactly. It's growing by 13%.
Now, if it was
Nice.
decreasing, it would be 1 minus.
Perfect. Yeah, if it's decreasing, it's all relative to 1. To the t, is that right?
-1.
Do we have to shift it somehow? I think that it has to be shifted just the number of years since they were first introduced. So 1 year later, it's 13% more. 2 years later, it's 13% of the 13% more. So growing exponentially. According to the model found in part A, what's the population of deer in the large wooded area after 6 years? For this, it would be appropriate to do by hand. Up to a certain point, right? This is about as far as you should go. By hand, and then you get your calculator, calculate the number, and round. Should we round to the nearest integer? 3 decimal places?
No, but if
You
you
can have a
can't
point.
have a part
It's
of it.
deer.
Yeah, you can't have a party deer. We're talking about living deer.
I got the answer.
The answer is, oh god.
So what is it?
I got one thing.
104.
104? Do we agree 104 deer?
You'd always round down. Yes.
Yeah, let's always round down. Oh, should I say deers?
No, it's.
That'd be incorrect. Yeah, because English is strange. No, but receive. Yeah.
I prefer E, except that.
Okay, so I think this is where it started getting a little bit weird, this kind of problem in the assignment. So I just want to make sure we're okay with this. But take a moment to discuss with your neighbor what we're able to figure out for this. We're trying to do it in months now instead of years.
It's on the same thing, but T is divided by 12. Since it shows like the yearly increase, so we measured in months, like the same yearly months. And since there are 12 months in a year. If you want to even go even further, you can just say 50, 3 to the 12.
It would grow.
Okay. So-
That's how much.
20 seconds.
It would be divided.
So you're getting rid of all the change. It's the only one.
Yeah.
Okay. So
That's a best.
let's focus up here for just a moment. I'm just going to talk about this, and if someone else wants to extend the concept or say it in different words, that'd be great. We're looking for this an equivalent expression just in terms of months. So I'm going to keep that 50 because that's where we started. The growth rate is 1.13. But this exponent is going to be different. And notice I changed to M instead of T. I think it's too strange to have T and T for years and months. So in this case, it's going to be M over 12. And let's just make sure this is the same, because here after 1 year, it's growing 13%. And here after 1 year, that means M would be
Well.
12. So it's still growing 13%. Yes? Okay, now the question is, in your homework, it was asking you to write it, I think, in an equivalent in just A times B to the T, wasn't it? So for that, how would we do this? Yes, Jonas?
Take 1.13 to the 12th root. And you should get like a value that's like that's like about like 1.010.
1.010. Something like that. Did anyone else get that? Yeah. Connor, do you have something to add?
We're supposed to keep the new increase or decrease percentage to 3 decimals, but that would be wrong.
Oh, you're right. The very end should be rounded. So it would be appropriate to at least do one more. So 1.010, one more. See, it would be appropriate to
Zero
to
point
have longer until the very end.
zero. Zero.
Yeah, similar.
Zero. 236.
But like when it gives you a fraction outside, like the 1.132 a fraction,
Mhm.
like I know the 12 becomes like the root, but for like the n length, it was like an x. Would that go outside of the parentheses or inside? Like if it was square.
It all is about, let's see, how can I write this? It's all about using this property. So, like,
Outside.
Yeah.
use it to your benefit. So what we see here is that the rate of deer is growing at a rate of, or the rate of growth of the population of deer is growing at a rate of
1%.
about 1% per month. And that works, doesn't it?
Yes.
Considering for the year, it's 13%, because this is compound interest. It's growing on it's exponential on the previous value. Are we good with this?
Yes.
From the homework, let's talk about the Facebook problem, shall we?
Facebook.
There was a Facebook question, wasn't there?
Oh, yeah. Oh, it's MySpace. Like the MySpace.
MySpace. So take a moment to discuss.
That last problem, we will just have like, I don't know, like divided 13 by 12.
That'll be a linear. We don't get a. It's growing like this.
This one asks for x minus 2. Oh, it's number of years. So.
Where am I? Assignments.
Wait.
I can't.
I didn't.
Made my best. And I didn't have a lot. Yes, you go. Yes.
It's gonna be the same, right? So
Okay.
Right?
Which one are you talking
Wait, no, you were supposed to.
Number 2 from the assignment.
I know.
And we're in 2.5. Pardon? And last 15 minutes.
And then you should make the class at least at 11.
Till 11 o'clock. Okay, so for 2A, should I just start with y equals 25 because that's the initial value?
Yes.
Normally I would if they just give us 2 points, they say here's the initial value. Here, there's so many points, we're gonna have to use the calculator here. Or Desmos. Are you okay using Desmos?
Oh, yeah.
Do you all know how to use it? Does it give you the same answer?
Should give you the same.
I think to get the same answer, you have to click a little button at the bottom, log mode. I think that will give you the same answer as that what your calculator does. Okay, so I'm not going to go over that. So, but what do you get? Y equals 31.602, 31.602 times
0.928
928
power.
to the power of x, which tells us, and we can see here that the attendance on MySpace is decreasing. It's decreasing and decreasing quickly. Do you know it was before MySpace, the big social media before?
We have a Yahoo.
Is that social media?
Was it AOL?
My grandma.
That was like a service
Or MySpace.
before MySpace. It was not the first.
We have the first letter.
Oh.
F.
Seriously?
That was after. That was after. There's a service called Friendster. Were you? There's a Friendster before. Yeah. But in any case,
Napster is like the music thing.
so I have 20 is approximately 7.11 users, million users. It didn't drop off that much. It's still in the millions. Is there still MySpace?
Yeah.
Yeah.
Is there?
What?
But now.
There
No
is.
way.
There's. It's not social media anymore. It's music, like artists, artists. I think demonstration. Okay, so we want an equivalent expression, but now it's the number of years since 2009. So we're going to start with the same. So y is equal to 31.602. Starts at the same place. This is going to be the same, but what is the new exponent?
Yeah.
12T.
No, it's.
I got 12T.
12T.
Never mind.
So this 12c, but let's make sure that this makes sense. Because here we're in,
It's 12.
is it not T? Yeah, 12 months of the year. So it's the number of years since January. So if we put a 1 here, would that be the same as putting
Wait,
a,
no, it's-
how do you get 1 over here? 1 year?
Don't
You just-
find someone.
Well,
It'd be 12, wouldn't it?
yeah, it's 12.
So isn't it the same thing? Like,
Yeah. It's
so if you were to try to do something like what we did before, if you try to do T over 12, it's just not a match. Like if you put a 1 here for 1 year, you have 1/12 of
Yeah.
I don't know how you would even. Well, 1 here, 1 month. There's no way to make them match. So these, you kind of have to work out the relationship here. So now we can rewrite it. 31.602 times 0.928 to the 12 to the T, and whatever that is. I imagine it's going to be much less than
0.48.
0.408. Do we agree with that? Which means in the year,
It decreases by.
increased by,
5.52.
decreased by
Oh, wait.
50, about like
50%.
59.2%.
about 60%, didn't it?
Wait.
By monthly, it decreased by 8%. So over the year, it's decreasing by 60%.
Wait,
For the year.
0.52.
Yeah, 59.2%. Because we're looking at a difference from 1. Okay, so I'm going to give you until 11 o'clock to either fill in what you need to do for your homework last time or to start on the homework tonight. You know what the homework tonight is? Pearson and
Sheet.
Packet. So yeah, 2.6. Let me just make sure we're clear with this.
Okay,
So this is Packet.
okay, to the bathroom.
Sure. This is Pearson. There you go.
Thank you.
Yeah. Sorry to be all over the place with the homework, by the way. Thank you for your. Yes. So this is Packet, and both of these are Packet. We've only had one Pearson. Yeah. Oh, this is 2.6 is a composition with Pearson.
How did you compose Pearson using?
Wait, is it
I don't know.
I put Pearson.
Or make a composite.
2.5? The last month?
Oh, yes, you're correct. Let me see. Just the one between your ears.
Again,
Did you charge it? Oh no.
oh,
Let me put the numbers up here. You're right. I should have them. I'm gonna stop the Zoom though.